Okay, these are the solutions for your third exam. This was question 1A. You had to talk about asymptotes and discontinuities. Okay, so the first thing that I guess we could do are asymptotes. So the highest degree is in the denominator, and therefore y equals 0 is the horizontal asymptote. And to find the vertical asymptote, we would set the denominator equal to 0. Some of you tried factoring this and doing all kinds of crazy things, but this is just x minus 1 times x minus 1 just times x minus 1. So the only thing we know is that if x equals 1, it's undefined. So at x equals 1, there's definitely a discontinuity. And you can look and see that's not going to cancel with anything in the numerator. So therefore, at x equals 1, there was a vertical asymptote, and that was also an essential discontinuity because it didn't cancel. Okay, now 1b was this. Okay, so if you want to look for the horizontal asymptote first, we can look and you can see that the highest degree is in the numerator, and if you used Jada's sign to help you with this, that was fine. But if it's at the highest degree is in the numerator, that means that there is no horizontal asymptote. And then to look for the vertical asymptote, we need to set the denominator equal to 0. And we get -5. So we know there's definitely a discontinuity there, but we have to see if anything will cancel with the numerator. And the numerator will factor to this. So there's no way anything cancels. So therefore, at x equals -5, there's a vertical asymptote, and then that means that must be an essential discontinuity. Each of these problems, by the way, was each worth 7 points. Okay, now we move on to problem number 2. For the first one, you did not have to show any work. You could just use that rule about limits that go to infinity. And what you're looking for is the highest degree. It's a 2 in the numerator, 3 in the denominator. So if the highest degree is in the denominator, that means that the denominator is getting bigger and bigger, which means the whole fraction is getting smaller and smaller, and it goes to 0. And that was the answer. Okay, part B. So many of these in class, so we're going to need to change cotan x to cosine x over sine x, change it into a division problem, change it into multiplication, multiply straight across, look for the rule, here it is. And now we're ready to take the limit. So the limit as x goes to 0 of sine x over x is just equal to 1. And if you look at the next part here, and you put 0 in here for x, you get cosine of 0, which is 1. 2 over 1 is just equal to 2, and 1 times 2 is 2. All these limit problems are worth 7 points, by the way, each. Okay, part C. We did a problem just like this in class. Everyone should have gotten this right. Okay, we can't substitute k in there, we'll get 0 in the denominator, so we're going to multiply by the conjugate. Okay, so in the numerator, you're just going to be left with x minus k, and you have this in your denominator. And x minus k and k minus x, they cancel to a -1. So if we clean this up a bit, we get this. And now I can go ahead and substitute in k for x. And 1k plus 1k is 1 radical k plus 1 radical k is 2 radical k. And that was the answer for part C. Okay, now part D. Okay, if you try to put 3 into the denominator, you're going to get 0. So we're going to have to factor. So the numerator factors to this. The denominator factors to this. Those cancel, and we're left with this. And I still cannot substitute 3 in there, so that would clearly indicate that this limit does not exist. But since you now know about asymptotes, you should have also realized that would mean that there would be a vertical asymptote here. So if there's a vertical asymptote, the limit's not going to exist. Okay, so moving on to number 3. Okay, so you have to determine if this was continuous at x equals 2. This was worth 8 points. So the first thing I'm going to do is f of 2. So when x is exactly 2, we're going to use the second function. Substitute 2 for x. You get 4 minus 10, and that's negative 6. Okay, then we're going to do the limit as x approaches 2 from the left side. So that means you're smaller than 2, so we're going to use the first one. Okay, so I'm just going to put 2 in wherever I see an x. 2 plus 2 is 4. 4 squared is 16. And a negative 16 plus 5 is a negative 11. So you can see that there's no way this is ever going to be continuous. So you had 2 choices here. You could either say that it's not continuous because the limit of f of x as x approaches 2 does not exist, so it didn't even meet the second requirement. Or a lot of you just wrote the limit of f of x as x approaches 2 does not equal f of 2, and that was fine also as a reason. Okay, moving on to number 4. Now numbers 4 and 5 were each worth 11 points. Okay, so we need to find a value for k that would make this continuous. So we'll start with f of 2, and when x is exactly 2, we're using that function right there. And that means wherever there's an x, I'm going to replace it with a 2. So I get 4 plus 2 is 6, so 6 plus k. Okay, now I'm going to do the limit as x approaches 2 from the left side. So I'm going to use the top function for that. Put a 2 wherever I see an x. So I get 2 to the third power, which is 8. 8 minus 4 is 4. And 4 minus 5 is negative 1. Okay, I do the limit as x approaches 2 from the right side, which means that I'm going to be using this function, but I already did that. I did that for f of 2. So I already know that this is going to be 6 plus k. Okay, the only way that this limit is going to exist is if the limit from the left and the limit from the right are the same. These two have to be the same. So I'm going to set them equal to each other. Subtract 6 from both sides. And if k equals negative 7, then the limit would exist, and this function would be continuous. And finally, we'll move on to number 5, which was a problem on the last test, and I warned you to make sure that you can do all the problems from the previous test. So for this problem, the first thing that you're going to do is you're going to change secant x to 1 over cosine. And then you're going to need a common denominator. Okay, now I can combine this fraction up in the numerator. I can create a division problem. Change it to multiplication. Multiply straight across. Okay, so that's what you get, and remember we're doing this as x goes to 0. So if I put 0 in here for that x squared, I still have 0, and that doesn't work. However, now, from that point, we have to multiply by the conjugate. So I'm going to the next page to make more room. So this is where I left off. Okay, so I'm going to multiply by the conjugate. Okay, and when I multiply that out, my numerator, I get this. Leave the denominator alone. So hopefully 1 minus cosine squared x looks a little bit familiar to you. It should remind you of this trig identity. And if I bring that cosine squared x over to the other side, I get this. So that means this 1 minus cosine squared x, I can trade it for a sine squared x. Okay, so my numerator is now sine squared x. Denominator stays the same. Okay, and because this x squared is attached by multiplication, now I can break this up. So I'm going to get this, this, and this. Okay, we're ready now finally to take the limit. So this piece over here is just 1. This piece becomes 1. And for this piece, I get 1 over cosine of 0, which is 1, times 1 plus cosine of 0, which is 1, and the whole thing becomes 1/2. That was the answer. Okay, and that's it. We're done. If you still have questions, make sure you let me know.